Welcome to Lecture 5 for CS420, and today we're going to be talking about local variables. Now you might have first learned about local variables in math. You might have had statements that say let A equal something, let B equal something else in this equation right here. And what you would do is you would take what A was equal to and you would replace the A's in the equation with that expression. So you can see down here the A's have been replaced with 1 plus xy. The B's have also been replaced with 1 minus y. And what local variables allow you to do is they allow you to abstract away complex operations. You can do some operations and then save the value and then use that value in future operations. This is much easier to kind of wrap your head around than an equation like this. You've used local variables in programming a lot. This is a function in Java or C. You have it's two parameters and then two local variables where you can do some calculations and save the result and use the result later on. Now another thing to note is A and B, the parameters, are also local variables. So why are they local variables? It's because of their scope. You're only allowed to use the variables inside of this block of code. A and B, Z and Y are undefined anywhere else in your code. And the main reason for limiting the scope is to make sure that you don't use variables that belong to another function inside of your function. If these variables are all global, one function might change it to one value and then this function might change it to another. And it could lead to lots of bugs. So this limits your namespace for local variables, so you know that those variables are only used in this block of code right here that you can see and know exactly what it does. And you don't have to worry about things happening in other parts of your code that don't involve these variables. That's why we have local variables and limit their scope. Now Recit has local variables as well. You create local variables with the let expression right here. Now in other languages like Swift and JavaScript, you might have noticed that to declare new variables you can use let. Another way to declare new variables is to use var. And let declares variables that cannot change their values and var declares variables that can. So in Recit, unfortunately, there is no var. When you declare a variable and you set it to a value, you're stuck with it. So the way this could read is let x equal 3 and y equal 5 in this expression down here. So we're going to take x, look it up and figure out it's 3, take y, look it up and figure out it's 5, add them together and we'll get 8. Now the syntax for let is fairly straightforward. You have the word let. Now remember the parenthesis in front of it means we're going to call the function let. And then the first parameter is a list of definitions that you want to create. And then the next parameter is the body. And the scope of these variables is only inside of the body. Now a lot of times I'll write my let like this. I'll separate each new variable that I declare on a single line, and then the body will be the last. The only thing that you got to remember is this open parenthesis to start where you want to declare variables and the close parenthesis at the end. So if we wanted to declare 3 variables, say b equals 7, then we can do that. And so you see that we have an open parenthesis that starts our variables, then each one is enclosed in a parenthesis, and then we have the closing parenthesis for that. Now this is just the body expression, and you can see this is a complex expression, but if we want to, we can just put a number here. Now this completely ignores all the local variables and just returns 45. Now there's two places where you'll see a variable name. One is called a variable declaration, and the other is called a variable reference. When we have a variable declaration, like in this let expression right here, we are telling our interpreter we'd want a new variable and we want to bind it to the value 3. That just means setting a equal to 3. So this is a variable declaration. Then later on is called a variable reference. That means look up this variable, find out what it's bound to, or its value, and use that value in my place. So this is a variable declaration, and this is a variable reference. Same thing up here. I've defined a variable x and have bound it to 5. So this is a variable declaration. Down here is a variable reference. Now the difference between this variable declaration and this one up here is this creates a global variable. Its scope is the entire program. We can use x wherever we want. This let expression makes a be a local variable, meaning we can only use it inside of the body. Now one good test, with all these parentheses you could get lost, but luckily Dr. Racket helps us out a lot. See how it's highlighted the code? From parenthesis to parenthesis, from the opening to the close, and we can see all of the area where this variable is in scope. Now we can see in this expression right here that the a's will get replaced with a 3 and this x will get replaced with a 5. So when we run it, we get 38. Now something that might not be as obvious is if we use the same name. What if instead of a we used x? And now which x are we referring to? This x right here and this x and this x are all of our variable references where we're using the variable. But are we referring to the local variable x or the global variable x? Now remember, the scope of this variable is only inside of the body of the let. So these two x's will be 3 and this x will be 5, and we'll get the same answer, 38. So now let's look at this example right here. We have a being bound to 3 and we have b being bound to plus a 1. So if we just look at this, we say, okay, a is 3 and b is 4, and we add the two together and we should get 7. But we don't. We get 4. Why do we get 4? The problem is the order in which Racket evaluates things. What Racket does first is it evaluates both of these right here. So it evaluates the number 3 and says, okay, I have the number 3. Then it evaluates this expression right here. So this is a compound expression. It's combining other expressions together. And inside of it, we're going to look up a. But this a doesn't exist yet. It hasn't created the binding for a yet when this is evaluated. So this a finds the global a up here. And so now 0 plus 1 is 1, and b gets bound to 1. Now after these are evaluated, then we create the new local variables a and b for the body right here. So a is 3, b is 1, we add them together and we get 4. So if we didn't have the global variable a and we tried to run that, we would get an error. Let me run this again. We would get an error, undefined a. And if you notice, this is highlighted right here because it can't find an a variable, so it's saying undefined variable. That's because the a up here has not been created yet. So this example shows how we can do what we're trying to do. The first let right here binds a to 3. And now the body, which is all of this, so all of that I highlighted is the body of the first let. So in this body, a is in scope. So now when we evaluate this, which is the first thing that the second let is going to do, is it's going to evaluate this. It looks up a and finds that a is bound to 3. And then this should have been a 1 right here. And then add 1 to it. And now b will be equal to 4, and when we add them together, it'll be 7. So that's what we want to do, or to have happen. Now this could get a little tedious, so there is a shortcut for doing all of this. And now the let star at the end is called a sequential binding let. What that does is it evaluates just the first one right here and says, okay, that's 3, and then it creates the binding. A is now bound to 3. Then it moves on to evaluate this next one. And then when it looks up A here, it finds the new binding that we just created to create the variable B. And so this will be 7 as well. Now I want to show you some Java code of creating new variables. So we declare a new variable x bound to 5 and a new variable y bound to 6, and then we just print out adding them together, which is 11. There's another way to create new variables, and that's by creating a function. So when you look down here, we create a new function called foo that takes in 2 parameters, x and y, and adds them together. And then we call foo with 5 and 6, passing in 5 for x and 6 for y. That's the same thing up here. We'll get the same answer, 11. X will be bound to 5, y will be bound to 6. Down here, x will be bound to 5, and y would be bound to 6, and then we'd add them together. So there's 2 ways to declare new variables, actually 3 ways to declare new variables in Racket. One is with a define, the second way is with a let expression, and the third way is through functions to declare new variables. We can do a similar thing in Racket. In this right here, we are declaring 2 new variables, x being bound to 5, y being bound to 6, and adding them together. Down here, we're creating a function, an anonymous function right here, and it takes 2 parameters, x and y, and adds them together. Now this parenthesis right here means we're going to call the function we just created. So lambda creates the function, the parenthesis in front of it calls it, passing in 5 and 6 as its parameters, and then we'll add it up together. Now both of these things will return the same number. So that returns 11, and this returns 11 as well. So we could take every let expression and convert it into this right here. Now this is really an application expression. We're calling a function. So we're applying a function to the parameters is another way to see that. So that's why we call it an application expression. So what we do is we take the body and we put it inside of a lambda expression. Then we take the variable names, and those become the parameters of the lambda expression. And finally, we take the values we're binding it to, 5 and 6, and pass them in as parameters when we call the function. So this isn't a nice way to declare new variables. It's really confusing, but this means the same thing as that. So a let expression is what we call syntactic sugar. Syntactic sugar are extra things that we have in our language that make it easier to understand. This is a lot easier way to declare local variables than this right here. This is calling a function and kind of confusing, whereas this is pretty straightforward. So we have lots of stuff in languages that make it easier to program, but are not exactly necessary. So we can do without a let expression in Racket and just use lambda to create new variables. Just like we can do without a for loop in Java or C++, because we can always use a while loop. We can convert every for loop into a while loop. We can convert every let expression into an application expression with a lambda inside of it. Now we're not just stuck to defining numbers or strings in let expressions. We can also define other functions. So these are called local procedures because square and cube are only in scope inside of the body of this let expression. Not something that we'd always want to do because usually when we declare a function we do it for reusability so we can use it more than once. Whereas if we limit the scope of the function to just this, then it's somewhat restrictive. But that doesn't mean we can't do it. So we can declare a new function and bind that to the name square, and another function being bound to the name cube, and then we can call the functions inside the body. So when we run this right here, we get the square of 3 plus the cube of 4, so that is 73. The cube of 4 is 64. The square of 3 is 9, so 9 plus 64 is 73. Let's look and figure out what this does right here. So we're creating a new variable f, and we're binding it to a function, right? And the function takes 0 parameters. See the empty parentheses right here? And then this is the body of the function. Now if we wanted this function to just return a number, we do that. But instead, we put a parenthesis in front of f. What does that parenthesis in front of it do? Well, it's calling a function. So the body of the lambda that we create is going to call a function f. So what is a function f? Well, it's a function that calls f again. So this is an infinite loop. To see this a little bit better, let's go down and look at this example right here. We create a new function called foo, and foo is going to call foo. So this is an infinite recursive loop. So if we were to call foo, then it would call this function, and then foo would call foo again, and then it would keep calling foo, and we get stuck in an infinite loop. So when we run this, we should get caught in an infinite loop. But we don't. It says undefined variable f. F is not defined. But if you notice, it's highlighting it right here and not right here when we first call it. When we call it the first time, f is bound, just like in our square and cube function. So of course it finds the function. The only problem is when it gets called inside of the body of this function, f is not defined. So this all goes down to the order in which Racket evaluates expressions. The very first thing it does is create a new function, and the function doesn't have a name yet. So the function is just going to call a function f. When it creates a function, it captures the environment. The environment is all of the variables that are in scope. So f, the name f, doesn't exist yet. So this function captures just the environment with the global variables in it. After we create the function, then the let takes over and creates a new variable name called f. But the function can't find it. That's why when we try to call f inside of the function, it can't find it. So the way to fix it is to use a let rec. The rec is short for recursive, to allow for recursive function calls. So what that does is it creates the variable name f first, then it creates the function so that the function can capture its own name in its environment, and then it updates what the variable is bound to, and it points the variable bound to the function that's created. That way the function can capture its own name. So if we run this, we're now caught in an infinite loop and I don't get another prompt. Luckily, I can just press the stop button right here and get out of it. Now to finish off this lecture, you should probably read through the logical operators. We got and or, and they are short-circuited, meaning as soon as and finds something that is false, it will not evaluate all the rest of its parameters. And that is called special form. Special form means that we have to evaluate operations in a unique order, not the normal evaluation order that Racket uses. So the normal evaluation order is first to evaluate all of the sub-expressions. So we see this opening parenthesis, and it's like, I need to evaluate my sub-expressions. The first sub-expression is a lambda expression. That's going to create a function. The second sub-expression is the number 5. So it evaluates 5 and it gets the number 5 back. The next subexpression is 6. So it evaluates 6 and says, yep, that's 6. So now that we've evaluated all the subexpressions, we now apply the leftmost, which is the lambda expression, to the remaining expressions. So passing 5 in for x, 6 in for y, and we run it and we get 11. So that is normal order. Now there are lots of functions in Racket that require special order. For example, define. Why is this special order? Well, if we did normal order, we evaluate define and say, okay, that's the function define. Next, we evaluate x. So we look up x to see what it's bound to, and then we crash. Because if we're just doing things blindly in normal order, we would evaluate this expression. It's a variable. We try to look it up in the environment and crash saying it's undefined. So define has a special order that it evaluates in. So and so it's called a special form. So when it sees that this is define, it will now modify the order of evaluation, evaluate what it's supposed to be bound to, and it will never evaluate its second parameter. It'll just create a new variable out of it. So how can you tell if functions in Racket are normal order or special form? Well, just type their name. If it's normal order, it'll give you back the procedure. If you type the define name, it will say bad syntax because that's special order. Let is special order, or an and are special order, but multiply isn't. What about that map function we talked about in the last lecture? It's normal order as well. So that's a quick way that you can check for normal order versus special order.